Okay, so in the next section we're going to talk a little bit about what you'll do in the lab. So in the lab you're going to be working through these little demos that are in chapter 2 of the Greenbird book. The first one is drawing a little house. So here is the outcome here, and it's been drawn just by specifying the precise coordinates of each of these things. The question is, what happens if we want to make it larger or smaller? So let's have a look at this code. So here's the code. Let's ignore what's going on in the background. The code is fairly simple. We say size 400, 600 to set up the window, and then we just draw a rectangle with a roof and a door. The roof is a triangle, the door is another rectangle. The doorknob is an ellipse, so that's just a circle with 6, 6. The windows, by the way, if you want to find out anything about each of these, you can double click on them, say find in reference, and look, there's the information for the ellipse, and you can read the parameters there, so that's easy. Then down the bottom we have all of the windows. So the question was, what was it? It was, what happens if we want to make this house a bit smaller? What happens if we want to, say, make 3 houses the same size? Well, if we want to change any of the sizes of the house, even the overall size, we have to go through and find out all of the coordinates one by one and replace each of them. So that would require a big, basically if you wanted to change the size of the house, nearly every number here would need to change. So you'd really need to do a lot of work. So it's not the best way of drawing. Ideally we don't draw with an absolute reference system because we end up being stuck, essentially. If you wanted to use a drawing to draw around a frame around the window, that might be okay, for instance, but anything else is going to require some better thinking. So let's close that. All right. So, whoops, just need to reopen my lecture. So the next example, or the other example, is an algorithmic face. So this is basically just a simple face, and if we take a look at it, you'll see it is just a face. So here's a face, it's got eyes, you can see pupils, so there's an ellipse with a circle and a circle. There's a rectangle for the eyebrow, a triangle for the nose, and a couple of arcs for the mouth. And there's an arc there, and there's a big ellipse for the head. Okay, so if we have a look at the code, you can see we start with size, then we set the background. Notice that we've set the background to 0. What happens if we change that to something else? Let's say 100. Changes to a grey background, and 255 changes to a white background. Now we can't see the face, so let's change the stroke to 0, and you'll see that now the stroke is black again. So let's set it back to what it was before. It was a black background and white stroke for the face. No fill means all of these have no fill values. They're just empty shapes. You can see through them. They're transparent shapes. There's no fill. Doesn't mean they're black. And here we've set ellipse mode to corner, so each of the ellipses will be drawn from their corner to another corner. Now we start setting things like the head height, and we decide that the head width is head height times 5/7. That's a little fraction to work it out. Head x and head y are the width and the height divided by 2. And then we base all of the other parameters here. We're just deciding the eye width, eye height, iris diameter, pupil diameter, based on head width, eye width, which is based on head width, eye height, which is based on eye width, which is based on head width. So everything comes off head width, head height, which is up here. Head width is based on head height. Then, once we've worked out all of the sizes, we begin drawing, and you can see there's an ellipse there, there's an ellipse there, but there's no numbers here, are there? There's only divided by 2's, but that is just halving it. There's no numbers saying this should be 50 or 200. So the good thing is we can look at head height and we can go, I want a smaller head. We can change that to, let's say, half the size. And we've changed all of our drawing commands in one go. So this is a good practice to get into. So there you go. There's quite a lot of different things happening, but they're all based on a single choice here. 600 for the height of the head, and you can do the same with your programs. So for variables, we've got lots of variables here. We normally use camel case for normal variables. So I width is I, no underscore, capital W, so that we can make out the width, and then the rest. So I width equals head width divided by 5. Notice the first letter is not capitalized. It's a camel case, and the camel's head is low, but the humps are high. You can also do expressions here, but don't forget the order of operations. In maths, for as long as I can remember, division and multiplication come before addition and subtraction. So left ix plus I width divided by 2 minus iris diameter divided by 2, that equates to actually left ix plus, in brackets, i.e. happening first, I width divided by 2 minus iris diameter divided by 2. One final thing. The face code uses arc to draw the lips, so you can mess around with this to try it out, but basically you set x and y of the arc, and then you state the width and the height, and the start angle and the end angle. So you're basically drawing a portion of a circle. Now this is the old-fashioned way of looking at a circle, but the way that processing looks at numbers is this way. We go 0, 45, 90, and around in a clockwise manner. So processing angles move clockwise around the circle, and it expects angles in radians. That's 0 up to 2 pi, not 0 to 360 degrees. You can convert degrees into radians really easily by just using the radians command. So you can say 0 degrees in radians is blah, or 90 degrees in radians is that. Finally, we do have colors. They're not just black and white. That's all I've shown you so far. But you can basically set the background to either black with 0, or white with 255, or grey with 100. But you can also state background and give 3 separate arguments, and that will be red, green, and blue. So your background can be a color as well. Fill 44 works on the same principle. That'll be a dark grey. But again, you can say fill and give it a color, and you'll end up, by a color I mean 3 values, red, green, and blue, and that will end up with a color for your shapes. And you can also have an alpha value. That can be for just the grayscale, so you can see through the shapes. That's really fun, by the way. And you can give 4 arguments, and then you have red, green, blue, and alpha. And then you've got red RGB values. There you go, 25500. So that would be a red background, bright red. Fill 0255127. So that's full green and not much blue, well, half blue. So it's a mix of 2 parts green to every part blue. And there's a fill for red, green, blue, alpha. Use alpha, it's great. basically, when you set a state for your colors and for your strokes, it stays until you change it again. So you'll have here, you'll set the fill to green, and every rectangle you draw will end up green. Same for if you set it to red, that will make everything red until you stop. So hopefully you'll look through chapter 2 of the Greenberg book, have a basic idea of how to draw with processing, understand coordinates, create basic shapes, use variables in processing, understand how to use arc, and also have a bit of an idea about how to use colors as well, as we just saw. Any questions? Don't forget to go all the way back to the start and ask questions using Slido. All right, thank you very much.